So I'm a senior data scientist at M&S. So go back a bit now. I studied mathematics at UCL. I started my career as a data analyst at Sainsbury's. So I worked a couple of years there, sort of introduction to sort of data world and retail. Then I moved on and worked at a consultancy called Capgemini for about 3 or 4 years, moving a little bit more into the data science world. So I worked on a couple of projects, mainly in the finance sector. So the project at HSBC and one at Lloyd's as well, quite a big transformation project I worked on there, looking at some of their data science problems. And then I worked for Cognizant after that, another consultancy working in their data science team. Also had a stint as a contractor where I was looking at sort of some marketing problems and setting up hypothesis tests and that kind of thing. And I've been at M&S since the start of the year, so since January, working mainly on this .com forecasting problem, which I'll talk to you all about today. And I'll just hand over to Andreas quickly, just so he can say a few words as well about his background.
Thanks, Charles. So yeah, I'm Andreas, also a senior data scientist. I studied maths, operational research, statistics and economics at Warwick, and then completed a conversion computer science master's. Then started life as a business analyst in an investment firm where I was using a lot of SQL, realized that I quite like the data side as a role. Went back to uni part-time to do a data science master's, and then transitioned into a data analytics role, mainly using Python and Tableau, and then from there into a data science role within a procurement consultancy, looking at invoice categorization. And then prior to M&S, I was at the Football Association, mainly working on things around like policy and the female game. And then joined M&S just over a couple of years ago. Predominantly been working on projects to do with foods or .com. Thanks.
Brilliant. Thanks, Andreas. All right, so we'll crack on with the presentation. All right, so just to run through what we'll be talking about today. So we'll give a little bit of background on Marks & Spencer. So hopefully most of you have heard about us, but give a brief intro and then delve into the forecasting problem that we've been looking at, progress to date, the approach we've taken to the solution, how our models improved over time, and also a couple of the models that we've looked at, so namely delve into kind of key learnings and then sort of conclusion of all the work we've done today. So a little bit about M&S. So hopefully a lot of you have heard of us. So we've got 30 million customers. I should say we're a UK-based retailer as well, but also with a global presence. We've got over 1,500 stores globally, and almost £11 billion group revenue. So that was for last year. Of that, about 3.3 billion is in clothing and home. The rest is predominantly for food. But what we're focusing on for our forecasting is online sales in particular for clothing and home. And that's still a pretty big number, which is over £1 billion, 1.12 billion. So that's what we're essentially looking to forecast on, so looking at pretty big volumes and cash value. So what is forecasting? So hopefully most of you are aware of what forecasting is. So I won't talk through this definition that I got from offline, but I mean, to keep it simple, it's essentially using historical time series data. So that's data that's indexed and ordered by time to make future predictions, sort of based on trends that have been picked up, seasonality, etc. And forecasts are used all the time. So not just by a lovely weatherman like Brad Pitt here, or as James said, he's got a background in meteorology, doing a lot of forecasting on the weather side, but businesses also use forecasting an awful lot, so that whether that's from a value perspective and sort of financial sort of budgets and that sort of thing, or whether it's more forecasting sales for sort of labor demand, which is essentially what our project is around, or it might be for a retailer, it might be forecasting availability of products, which is very important to make sure that there's no lost sales, and that's it's available to the products are available to the customer, etc. So so that's just a little bit of background on forecasting. In terms of our problem space, so as I've mentioned briefly already, so we're looking to forecast sales volume of online sales. So currently the process is being done by the business is very manual and Excel based, and what it's being used for is essentially to plan out labor in our online distribution center. So making sure that we have the right labor in the right place, if you get your forecast correct. So we're trying to essentially automate and improve the accuracy of the current forecast, and that should result in a reduction of labor costs in the warehouse, and also ensure that the products are processed on time and therefore they get to the customers on time, which is really important. So the current process today by the business is some of our online teams do a cash sales forecast, then they convert it to gross sales, which is essentially removing returns, which is kind of a separate process altogether. Then the cash value gets converted to volume using average selling price. That's what that ASP is. Then the volume gets broken down to sort of chamber and hourly levels, and there's different breakdowns, which is done by a distribution center labor planning team. Then they get some buffer added on just because of sort of lack of confidence with the models and sort of previous performance, and then that's how we get to a final sort of labor planning view. So that the big problems, I guess, right now is that it's a manual process, and there's also several interventions throughout the week, which means that the labor teams have to react to sort of last minute changes. And also a lot of the conversions that I mentioned there are generics, like the average selling price is just sort of fixed number, which does change every week, but that will kind of you'll lose accuracy in model essentially by just applying generic conversions. And then there's also this additional buffer that gets applied just due to lack of sort of confidence. So we're hoping by having a more accurate forecast that there'll be more confidence in the model, in the model performance and the forecast going forward, and therefore that buffer won't need to be applied, which should save money for Marks and Spencer. So in terms of progress to date, so we've done a lot of sort of data collection so far. So we've looked at various sources. So we've got promotional information, weather, availability, stock, and various other things, sort of marketing campaigns, we flag holidays, events, etc. So that's a large part of so any data science problem is that upfront work to get the data. We then essentially built a POC, proof of concept, and we've been trialing how that's been doing and running our forecast tool in parallel with the business still forecasting, and essentially looking at like-for-like comparisons for how our forecast is doing. So the next step, which is kind of where we currently are, is just essentially looking at sort of kind of performance of the model to date and learning from what's happened so far. In any sort of poor weeks we've had in the trial, we've tried to see what features we might be missing or what we might be doing wrong. Obviously, we've got Christmas coming up as well, which is an incredibly important time of year and very volatile as well. It's very difficult to forecast. So we're kind of learning from what we've done so far to focus on where we've struggled so far and on the really volatile periods of the year. Next thing we've also started to look at, so Andreas has done some great work starting looking at breaking down our forecast. So currently it's quite high level. So we look at business unit level right now, and business units are stuff like women's wear, men's wear, kids wear, lingerie, beauty products, etc. So it's pretty high level. We're looking to start break it down to sort of delivery type. So that includes click and collect, standard delivery, next day delivery, etc. We also forecast at a daily level. The distribution center and the labor team need an hourly view so they can allocate their resources on an hour by hour basis. That's something we're looking at. And also we have different chambers in the warehouse. So we have box products, hanging products. We also have an automated sort of conveyor belt section of the warehouse, when they all have different processes. So they need to be forecasted separately. So that stuff we're sort of due to look at. And then the final thing here is sort of hierarchical forecasting, which we've only touched upon so far, but it's something we'll definitely have to look into more in the future. So this is around when you've got different sort of granularities of forecasts. If you've got a forecast at a total level, but you've also got a forecast hourly, by delivery type, etc. All of those forecasts need to aggregate to the same number. So that's essentially what hierarchical forecasting does. It just ensures that everything reconciles basically and makes sense, and kind of optimizes the different forecasts and make sure they add up to the same value. So that's something we'll be looking at in the future. So in terms of the approach we've taken, so I've mentioned the data part already. So we're bringing in sort of promotional information, stock, events and key dates is also really important. So you've got your kind of regular things like bank holidays, but you've also got other events that happen throughout the year. Easter obviously happens at different times of the year, and there's other religious events, sporting events, etc. So that's all really important. We bring in weather data as well, and there's also other business forecasts that we factor in to our own. It's important noting as well that we need a historical information for all of these different data points, but we also need a forward-looking view. So in order to forecast sales going forward, we also need a forecast for weather, promotions, etc. And we've had to actually build separate models for promotions and availability so that we predict what's going to happen for those, and that then feeds into our main model. But we'll talk about that in a bit more detail soon. We've also set up the model so that it's quite flexible in terms of, we can set the start date and then the forecast horizon, which is kind of how far ahead it forecasts for, is also flexible. So we're looking at quite a short-term horizon right now. So we're looking at the following week, but we actually forecast on a Monday for the following Sunday to Saturday. So we actually need about 12 days forward forecast, but only the last 7 days are important for us. So it's quite a short-term forecast, but there's flexibility to change that right now. And we forecast for different business units, as I mentioned. So the ones we're focusing on right now are the sort of 4 biggest, which are menswear, kidswear, lingerie, and women's wear. There's a couple we haven't included yet, but that's sort of on our backlog of things to do. So I mentioned already, we forecast a daily level, so for a week, but we get the daily forecast numbers. And sort of next step is sort of start breaking that down to, as I mentioned already, sort of hourly level, delivery type, chamber type, etc. And then finally, we'll be looking to produce some kind of interface. We'll have to work with the UI team. Haven't looked at that too much so far, but this tool that we're producing needs to be available to the business, to the people within M&S who are relevant, who this is relevant to use. So yeah, we did a bit more thinking on that, but there needs to be the ability also for them to see why the model is forecasting the numbers it is, and maybe flexibility to tweak the numbers if needed, or add, if something changes, like a promotion ends early or the weather changes drastically and that's not picked up in the forecast, there needs to be that kind of user ability where they can flex stuff and rerun the model to get new forecast numbers if needed. So in terms of performance over time, so just throwing what we call a vanilla model, which is essentially just, basic model without sort of doing anything to it really, so just putting the data in, you see the performance is actually pretty poor. So this was at the start of the year in Q1 where we kind of first started developing the tool and doing proof of concept, but over time you can see that the MAPE has reduced. So MAPE is mean absolute percentage error. So we essentially take a daily percentage error, so look at the forecast value versus the actuals, look at the percentage difference, take the absolute, so basically make it positive, and then take the average for the week. So that's basically what MAPE is. And MAPE is quite a common sort of metric for measuring performance of a forecasting model. So that's how we measure accuracy. So basically, the lower the MAPE, the better. So you can see in the chart, the MAPE came down over time. So in Q2, we got pretty close to where the business were, but the business were actually improving as well. So there's a bit of competition there between us building this tool and trying to improve on the forecast, and the business teams actually making improvements themselves. But over time, we've managed to get that the error rate down even more. So we've been beating the business now quite consistently for the last few months. And those sort of improvements have come over time with a bunch of sort of features that we've added. So feature engineering I've mentioned here is really important. So that's basically making sure you have the most relevant features in the model, and you're excluding anything that's not having a big impact. So just simplifying the model essentially, which also helps to improve your accuracy and make the model more stable. We've also done a bunch of hyperparameter tuning. So we use something called HyperOpt to find the optimal hyperparameters for the models we've been looking at. So it's more efficient than sort of standard methods than sort of grid search and random search. So basically grid search, you specify sort of parameter values to try, and it just tries them. With HyperOpt, you can give a range of values and it will try all the values in that range basically. So, and it's a lot more efficient in terms of running time. Another big thing we've added is cross-validation. So rather than just using sort of simple train test, or sort of one train period and one test period, we've essentially set it up so that we have different sort of folds of train test periods. So for instance, if we're forecasting for Christmas this year, we'll train up until the Christmas period from last year and test on the same sort of Christmas week, and we'll also set up our train test to look at the Christmas before. So but essentially the model is optimizing on the same week of the year, same week of the year, but from previous years. So we found that to be really efficient in improving the accuracy of the model. And yeah, also looked at sort of correlation of features. So when we first started doing the feature engineering, just threw all data points at the model, but we actually found we had like multiple features for promotions as an example, and some of them were highly correlated. So we essentially did some analysis to look into that and removing the highly correlated features. And again, it sort of simplified the model and actually improved performance. So yes, we've got the model to quite a good place so far. So we talked a lot about sort of the modeling and using machine learning, but we haven't actually talked about the models themselves. So we tried a couple of models when we were first looking at this problem. So ARIMA was one of them, which is one of the better known time series forecasting models. So I'll just run through a little bit about what ARIMA is, and then I'll hand over to Andreas afterwards to talk about Profit, which is another model that we looked at. So ARIMA stands for Autoregressive Integrated Moving Average. So autoregressive just means that the model essentially takes into account the performance or the weighting of data from historical time periods, and looks at sort of lags of different time to see kind of what periods of the year actually have the biggest impact on the output of the model. So that sometimes might be referred to as P, which is the number of time lags. Then the integrated part. So for ARIMA to work, we need to make the data stationary. So this integrated part essentially does differencing on the model. So it essentially subtracts sort of previous values from current until the data is stationary. And what that means is the properties of the data when they're stationary don't change over time. So the mean and variance don't change. So it essentially eliminates any trends in the data, and ARIMA sort of does this automatically, and that's necessary for it to perform efficiently, and that's sometimes known as D, which is the number of times that the data is differenced. Then the other part is moving average. So we essentially, or ARIMA takes averages of or tries out taking moving averages, so averages of different times, historical times of year, and Q is the size of that moving average window that it takes. And essentially, by taking moving averages, it eliminates any outliers and just smooths out the data a bit. So we haven't talked about seasonality, so that's another thing we can add on to ARIMA. So it becomes SARIMA with the seasonal aspect, so that the seasonality part essentially creates its own set of PD and Q arguments. So basically all the ARIMA parts it will figure out, but just for the seasonal aspect of your data. So I've got an example here. So if your data points are monthly and the seasonal cycle is a year, then your S, which is your seasonal part, will be set to 12. So for us, because we're looking at daily data and forecasting at a weekly level, S would be set to 7 in our case. But yeah, that's incredibly important for a lot of time series problems, is that you have to consider the seasonal aspect. And the other important part is what I've talked about already, which is the exogenous, which is essentially external variables. So they can include environmental, economic factors, which are also having an impact on your time series data. So as I mentioned already, we've added stuff like promotions, holidays and events, availability, etc., which will go into sort of that exogenous part. So that's ARIMA. I'm just going to hand over to Andreas to talk through profit and the rest of the talk.
Thanks, Charles. So yeah, I'll talk to you a little bit around profit. So profit is an open source forecasting tool that was developed by Meta and then made open source back in 2017 and is available both in Python and R. So it's pretty robust to missing data and sort of changes in trend and handles outliers pretty well. At its heart, it's a decomposable time series model. So there's the sort of 3 main elements in the base model that's around your trend or sort of growth, seasonality, and holidays and events. So the growth is a piecewise, either linear or logistic. You can also set it to be a flat growth as well. And when we talk about piecewise, what we can do there is select points in time where that trend changes. So you see things like COVID, we've seen trends for online start to go up. And then as we've sort of reached a more normal period, those upward trends have stopped and we've got into sort of a more sort of stable, or in some areas decreasing sort of path. Then seasonality, so depending on what you're trying to model, you might have yearly, weekly, or even daily if you're looking at hourly data. So in our problem, we're just looking at yearly and weekly. And then holidays and events. So some holidays happen same time every year, so they'd almost be captured within seasonality, but you'll get some events which things like Easter will move around, but again, things that are sort of business specific. So when we run a back to school sort of discount schoolwear campaign, when we run specific loyalty offers, they will change over time. So this gives us that sort of flexibility to tune the model and add in additional event data. And then it also adds in a little bit of noise when it's training, just to capture some of those fluctuations. And then finally, it's not in the paper, but it is something that is easily visible on their website, is around adding sort of extra linear regressors. So something that Charles talked about on the previous slide, but also something we showed earlier around some of the other things that we wanted to add in, whether that be weather, whether that be promotional information or availability. And then that takes us quite nicely to the key components element, working out how much of the forecast is attributed to which part. So what's quite nice is that Profit has an inbuilt sort of graphing functionality. So you can see from these graphs here, it sort of explains what the current trend is, also explains the uplift or downturn based on sort of what time of year it is, or the weekly seasonality, and then those holidays as well. So you can really see, once you add holidays in, sort of what impact that's having. And then also our extra regressors as well. There are a few issues in the way that this is displayed. So things like it being a percentage can be quite difficult to work out how that actually relates back to a value that is sort of an absolute volume. And things like yearly, it's going to be quite difficult to work out from that graph what specific number you're talking about there, because it shows the whole year graph, which leads us quite nicely to this waterfall graph that Charles has done some excellent work creating this graph to make it a lot more explainable what impact each feature is having. So this allowed us to sort of visualize both at a day level and at a week level as well the impact of each individual feature, which was vital for sort of giving that explainability to the business, but also for helping to root cause certain features. So sometimes you might have specific events data. So it might be a sporting event that appears once or twice, but appears during a period where there's high seasonality. And we had that issue a little bit with Wimbledon in the summer, and it's sort of mapping some effect to Wimbledon that we weren't expecting. So it really helps to sort of not just explain it to the business, but for us to get a sort of visual sort of response of what the model's doing, so we can look at what we want to add, what we want to remove. And then we'll move on to sort of with a bit that you're most interested in hearing about, is sort of our trial results. So as Charles mentioned earlier, obviously we were back testing prior to this. We got the model to a point where our forecast was beating the business, but before we went to a live trial, obviously we went through the process of an offline trial, or a dress rehearsal as we called it, where we were producing the numbers and sending them to the business, but in terms of labor planning, they were still using their own numbers. This allowed us to track across those 4 weeks just to show how the model was performing, and across those 4 weeks we saw a reduction in MAPE of just under 1.3%. And then from there we had the confidence from the business to then move on to a live trial. So we've just completed a 6-week live trial, and what we've found is that we've got a slightly lower improvement in MAPE, but still sort of around that 1% mark. So 0.8% reduction, but in all of these periods, what we were seeing was a mean absolute percentage error of less than 10% from both us and the business. We also found that we were at a day level more accurate 60% of the time, and our worst week we were better on 2 out of 7 days, and our best week we were better across all 7 days. And then from there we'll talk about value. So how does a better forecast sort of translate into value? So there's 2 key elements really. So it's trying to get that balance right, because there's there's sort of an additional cost if you over forecast. So if you over forecast, you'll end up with too many people within the distribution center. Say if you only need sort of 10 people, but you've brought in 12, then that sort of variable cost of labor is 20% higher. And then in contrast, the sort of under forecasting element, if there's not enough people, then generally what happens is we have to push out our delivery times. So Marks Spencer's has 3 different delivery types: click and collect, nominated day delivery, which are both next day, and then standard delivery, which is generally 2 to 4 days. So if there's not enough resource, those will get pushed back. So click and collect might get moved back to 2 days, and then standard might get pushed to 3 to 5 or 4 to 6. And we know from there that we see a lower checkout conversion. We also know that there's then more sort of contacts to the customer center and sort of a lower net promoter score as well. So getting that balance right of whether we're making sure we're not sort of biased towards over or under just is really important. And then next steps. So I think Charles touched on this a little bit earlier. So firstly, expanding the scope. So we forecast on sort of 4 business units at the moment, but there's other business units that are fulfilled by the distribution center. So the aim is to expand to forecast across all of those. And then looking at those different delivery channels, so the click and collect, nominated day delivery, and standard. Then now that we've sort of got 10 weeks of trial, look to incorporate some of the learnings that we've seen, so additional features, and then forecasting at different levels, whether that's forecasting at a total level, whether that's going slightly more granular than business unit. And then one of the other things that we've seen is around our day of the week split. So we talked a little bit about weekly seasonality earlier, but one of the things that Profit allows you to do is set different periods of weekly seasonality. So it might be that you have a different weekly seasonality up until people started sort of working from home for COVID, and then you set a different period of weekly seasonality where we sort of see that people are more likely to spend online during the week when they're working from home. And then finally, forecasting over longer horizons. So currently we forecast over that 12-day period and look at the last week. There's also benefit to looking at some of the longer periods so that we can help sort out labor allocation of our permanent staff as well as agency, and then over a much longer period, just to give the business that better ability to plan longer term. And then key learnings. So one of the things we found was the model really struggles when demand's being driven by a combination of impacts. So particularly around where we see that sort of weather changes, so where it might have got colder over a period of time, and sort of season launches as a combination. So when it starts to get colder, more people will start to buy coats, but that might be slightly sort of inflated by the fact that there's a new range of coats. Then one that I highlighted before around work to be done on weekly seasonality, about the change in customer behavior over time. And then business that we've found have been okay with the occasional spike in error, as long as there's some sort of explainable reason behind it. So where it's that sort of combination of effects, and we know that the model can't model those combinations brilliantly. But this is where the waterfall graph as well really helps to explain what the model thinks is happening, so that we can then sort of add commentary to that around what we think it's missing, so that we can develop that in the future. And then finally, as you saw from the sort of MAPE over time graph earlier, you can't just throw sort of the out the box model at the problem, you will get a reasonable output, but we saw that it was obviously worse than the current forecast, and we needed to add things like additional features, tune the parameters, cross validation, just to bring that error down, which it's good learning to understand what impact different features had, and the importance of some of these things. And then conclusions. So the model is performing well. We know that there will be blips on certain days, just where it's difficult to explain just certain events, like during those 10 weeks we had the death of a monarch, change of prime ministers. There are things that the model's just not going to be able to pick up, and there's just natural fluctuation it won't be able to pick up anyway. We expect that now that we're in a more sort of stable period after the sort of chaos of the last few years, that the model should naturally improve over time as we start to see sort of more stable seasonality and sort of the end of lockdowns. Then extracting value is a lot more difficult than probably initially expected. So obviously there is an element of the resourcing that we spoke about and lost sales in the previous slide, but there's also a lot of other things that have been going on, particularly recently, around postal strikes, and then on the Queen's funeral, the distribution centre being closed, and then there's the cumulative effect of if you're slightly out for a number of days, then it's going to cause an issue. If you sort of continuously under forecast or over forecast, that will impact you. Whereas if you were to oscillate between under and over forecasting, you'd probably be able to get away with it a bit more. And then finally, just talking about the sort of continuous improvement. So taking those learnings that we've seen from the trial, working out better features to try and bring that error down as much as possible. And then I just wanted to thank everyone for listening, and just highlight that we are hiring. So if anyone's sort of enjoyed what they've heard, wants to know more about M&S, please get in touch or look on our website for available roles. And